Okay, for this problem, we are making calculators. Some of these calculators are normal graphing calculators, and some of them are computer algebra-based calculators. Now, we are told our variables up here. We have G, which is the number of graphing calculators, and we know we can't have a negative number of graphing calculators, so we have one inequality. We are also told C is for the CAS calculators, and we know that can't be negative because we can't have a negative number of graphing calculators. Once again, your limitations or your restrictions help you come up with your other inequalities. Those come up here. We have a total of 85 worker hours for production, and we have 40 worker hours available for encasement. So those are going to help us with our other inequalities. So if we look at this for our production hours, we have some of our production hours that will be used for the graphing calculators, and then we got to add in other production hours that will be used for the CAS calculators. And according to what it says, it can't be more than 85 hours, so it has to be less than or equal to 85. Similarly for the encasement, some of our encasement is going for the graphing, and some of our encasement is going for the CAS, and it can't be more than the hours available, which is 40. So as we look here, we can look at our production. Now, we know for our production, which is in red, it's 1.5 hours for each graphing calculator. So I'm going to go 1.5 times my graphing calculators. Then I got to add in my computer algebra, which is 1 for each computer algebra. So it's a 1 times a C. So as I look over here at the blue, for quality control, I'm going to have 2 for each graphing. So it's going to be 2 times each graphing. And then a half or 0.5 for each computer one. So when we write that out, we get this here. So I'm going to go ahead and try to go ahead and work this out, and we can graph this. We're also asked to do the profit. Well, we know the profit is $50 for each graphing, so it's 50 times your graphing, plus 65 for each other one. So we need to go ahead and graph the 2 purple ones, and that just limits us to the first quadrant. Then we need to go ahead and graph the red, and we have to graph the blue, and then find our corner points. Now, just like in the last problem, when we are graphing these, I'm going to choose to go G, C, doesn't really make a difference. That just happens to be the order that I have my equations in. And I'm going to plug in 0 for my red G. That allows me to find my C, which is 85. Then for my plug in 0 for C, and then I can work backwards and find out what my G value is. And that is 50, oops, come on, right, 56 and 2/3. Now I can go ahead and do that same type of thing for my blue, which is, I got to keep my letters the same in my T-chart. 0 for my G. Then I can find my, if G is 0, then I get 80. Then I can plug in 0 for C, and I can find G, and that would be 20. So then I'd want to go ahead and graph this. With what I have for my letters, and I put my first letter in my table is G, so that's going to be my x-axis, so this is C. So when I'm graphing the red, I got to go over 0, up 85. That 8 didn't turn out nice. We'll try that again. Then here I have to go over 56 and 2/3 and up 0. 56 and 2/3. Now we can't really have 2/3 of the calculator, but that's the way the math ended up being in this point. Then we can graph the blue, over 0, up 80. and then over 20 and up 0. So I can draw in the blue, I could draw in the red. In this case, we would then be shading in here. I can find my corner points. Here's my one corner point. I already have that. Here's my other corner point. And then this corner point is just where the intersection of the two lines are, which is 1.5 G plus C is equal to 85. And then my other one down here of 2G plus 1/2 C is equal to 40. All we have to do is just solve that equation. Then we can plug all those corner points into the profit and answer the question.